So right now we're going to talk about how we took all the different JPEGs that we just scanned with our LiDAR sensor, or with our LiDAR, and then converted them into this 3D point cloud. So all of these files are on the Pi, similar to the scan that we did in our room. Right, we've got them here, right there. They're labeled again by the angle at which they were taken with respect to the horizontal plane. And then we use FTP. We use this this file transfer protocol that we can log directly into our Pi, and then we can just copy the files themselves into this folder, which we've already done here, and then we can kind of take a look at them on our desktop, right? We don't have to worry about them being on the Pi. And the reason why we're doing that is because we have a lot higher processing power from a laptop than a Pi. My laptop is significantly more powerful than a Pi, which makes the whole process faster. And so now that we have all of these different images in a folder, let's take a quick look at them. Right, so I've labeled this one outside scan, so we can see these images. Right, we've got some of the higher angles, higher being like above 0 and less than 40 would be like everything above 40 is actually below the horizontal, so the 300s are below the horizontal. I could say 360 and 0, we're just at the horizontal. Right, we can see that we're kind of getting these cross sections, and the difference and the distance between this line, between these laser dots, and then this line is going to inform later the point, the XYZ coordinate of the point where this is actually, the farther that this dot is from this line is indicative of, or rather the relative distance between this point and this line is going to indicate the distance that the object that's reflecting the light is from the sensor itself. So we take this and then we run it through this code. We're importing a number of packages here, right? NumPy, OpenCV, IMUtils, glob, re, and time, and matplotlib, a number of other packages. And then when we run this code, basically we're able to generate these 3D point clouds, which is what we're going for. So we see that we generated these 3D point clouds. We can take a look at them here. So in Python, it's not so much to look at, but I've also run it here in MATLAB, and we can kind of see the outline of this academic testudo kind of starting to show up on us, which is good. You can see these are the legs, right? This is the ground. Above here, the light starts to interfere with it, so we might want to use a dynamic mask for that, right? We could have like multiple, split up the code into multiple pieces and then run it, at different times. Also, with different mask values. Also, using a brighter laser would help. So I'm gonna look for one of those.